Today, we're going to be presenting our solution for the Global Legal Hackathon. Our solution is focused on location-based data privacy. We are members of Drexel University, and we are a combination of privacy legal experts in statistics and the law. So I first want to start by outlining what our project goal was. And so we were really focusing on the trade-off of the accuracy of location data with privacy components that go along with that. And so our goals were to look at legally defined terms and match those to use cases of location data, and then to develop a statistical solution to reduce the identifiability of individuals while maintaining the usefulness of that data. So really looking for that privacy tipping point in using statistical analysis to use location data while also not violating the privacy rights of individuals. A core component of our project was looking at core privacy terms that we have when it comes to de-identifying information. And one thing I want to highlight is that oftentimes these four core terms that you see here are used interchangeably. However, different regulations and legal standards will often define them differently, and these nuanced defined differences have real ramifications when you're looking at how to use, especially geographic data, to diminish, to keep the usefulness of that data while also maintaining the privacy rights. And so our project really took two of these core terms, anonymization and aggregation, and piloted a statistical solution on how to find data that was going to be useful from a geographic standpoint, but the least invasive of those privacy rights. So I'm going to turn it over to Cameron to walk you through that statistical analysis.
Thanks, Jordan. So our statistical analysis, what we called it is location coarsening via rounding. And it's a fairly simple approach. What we did was took all of the latitude and longitude measurements for individuals that were in our data, and we rounded them to different specificities. So the figure on the right here represents sort of the trade-off between the number of decimal places that exist in a person's location measurements and how unique that person's location is when compared to everybody else in the data. So our approach actually improves privacy in two ways. The first is it reduces location uniqueness, because by rounding the latitude and longitude values, you're going to have more people that have the same location measurements at the same times. The second way it improves privacy is it actually alters people's original locations by a distance that we can control by choosing how much we round the values. And so this achieves, the anonymization and aggregation of these people's data because it's no longer representative of individuals' exact locations, and you can no longer link it to other data on those individuals because you don't know exactly where someone has been. And if you actually want to see more detail of this analysis, we've provided all of our code and our data in a GitHub repository that's linked in the bottom left of this slide. So now we'll turn it over to Matt to discuss some of the privacy metrics that we've analyzed.
So I'm going to talk to you about four different statistical metrics that app providers can use to analyze COVID-19 via location apps with GPS data. So the first is a neighborhood risk. Essentially, it's what % of the people in my neighborhood have coronavirus or COVID-19. In this case, privacy is the best because we're using aggregation. The next metric is specific location risk. So you can think about maybe a grocery store. So now we're focusing in on that grocery store, and we're looking at the number of people in a specific day that were at that grocery store. And the privacy risk here is medium. Finally, there's contact tracing, which is pretty popular using both Bluetooth and GPS. And here, if somebody is close enough to another person, that's considered a contact. So what results is actually a social network like Facebook. And this data is not very private. In fact, you can figure out all of somebody's friends just from their contact. And then finally, the last metric is what we're calling quarantine compliance. So this is if a person leaves their home then there's a violation, right? And here privacy is non-existent. Examples, Hong Kong, Poland, and essentially you just have to trust that the government agency doesn't release this data.
So based on this project, we have identified a number of areas of future work to continue to build out this balance between privacy and the geographic location tracking. So first is we want to identify and define the privacy risks that are inherent in using geolocation data. We want to further define these key legal terms that we identified earlier and the factors that have with the corresponding statistical analysis. And finally, we want to use differential privacy for the approach to geospatial data, which provides a theoretical guarantee to individual privacy. So these are future areas that we've identified that we hope to continue with our research and our development under this project.
So if you have any questions or if you're interested in working with us in the future, please don't hesitate to reach out. I'm a first-year PhD student, and right now my dissertation is focused around privacy of location data. So this is something that we're going to be working on for the foreseeable future.
Thank you.
Thanks, everyone.
Thank you.